Hi everyone, we're going to be talking today about how to raise an exponent to another exponent, or power of a power rule. So our first example, we have x squared raised to the second power. So what that's saying is we're going to be multiplying x squared times itself 2 times. We have x squared times x squared, because it was raised to the second power. Another way we can write this is x times x for our first x squared times x for our second x squared. So altogether we've got 4 x's being multiplied. Now to figure out what this is equal to, we have 4 x's being multiplied, and if we think about last time when we had all the same base with no exponents up here, right, they're really like exponents of 1. So then what we did was we took our exponents and we added them. So altogether we have 4 x's, and 1 plus 1 plus 1 plus 1 gives us x to the 4th. So in simplified exponential form, x squared to the second power is x to the 4th. For our second example, we have x squared to the third power. So in this time we have 1 extra set of x squared. So again we can write it the same way. X squared times x squared times x squared, right? That's 3 of them being multiplied. Or we can write out all of our x's. We have x times x times x times x times x times x. 2 x's here, 2 x's here, 2 x's here. So all together, if we added our exponents, we have 1 plus 1 plus 1 plus 1 plus 1 plus 1 gives us x to the 6th. For our next example, we have x to the 4th to the second power. So this time we're multiplying x to the 4th times x to the 4th, which then would give us 4 x's being multiplied for the first part for x to the 4th, and then 4 more x's for our second x to the 4th. So now we have all these x's and we have 8 x's total. So we have x to the 8th. For our last one that we're going to try together, we have x to the 5th, and then that's being raised to the second power. So here we would have x to the 5th times x to the 5th, which would give us 5 x's times 5 more x's, which would give us a total of x to the 10th. So you may have noticed a pattern here. When we have an exponent raised to another exponent, all we have to do, instead of writing all these out and counting how many x's we're going to have, is multiply our exponents. 2 times 2 here gave us an exponent of 4. 2 times 3 gives us an exponent of 6. 4 times 2 gives an exponent of 8. And 5 times 2 is an exponent of 10. So that's going to be our rule. If you go down to the bottom here, the fancy way to write this, if we have n to the a raised to the b power, we're going to multiply a times b, and it's just going to look like this, n to the a times b. Now what I want you to do is pause the video and try these 4 on your own. Once you're done, you can restart the video and I'm going to go over these 4, but please try them before you listen to the answers, because I want you to make sure that you're on the right track. Hopefully you've paused the video and you've come back to check your answers. Okay, so our first one, we have 4 squared to the 4th power. So you're really multiplying these exponents, right? So we would have 4 to the 8th power, and then 4 to the 8th power would be 4 times 4 times 4 all the way 8 times, so it would be 65,536. If you just wrote this, that's okay, but on our test we're going to actually want to solve these out and multiply it all to get our final answer in standard form. Our second example, we have x to the 5th raised to the 5th power. We're just going to multiply those two. So 5 times 5 gives us 25, x to the 25th. For third, we have x to the 3rd raised to the 10th power. Again, we're going to multiply. 3 times 10 gives me x to the 30th. And our last example on this page, x to the 3rd raised to the 5th power. 3 times 5 is 15, so it would be x to the 15th. Okay, next we're going to move on to our next page, and we're going to talk about the power of a product rule. So here, we're raising things to a power. So sometimes they have exponents, sometimes they don't have an exponent there, but they all have coefficients. If you see, here we have a 3, a 4, a 5, and another 3. And then sometimes they have more than one variable, so we're going to see what that looks like. So it's pretty similar to the one we did before, but just a little extra stuff is being raised to the power. So the first one, we have 3x to the second power. We can write that as 3x times 3x, right? You're multiplying 3x twice. So then you would multiply your coefficients just like normal, and we would get 9, and then x times x is x squared, right? You would add those exponents, and remember, if you can't see the exponents, it's like they have an exponent of 1. So 1 plus 1 would give us 2x's there. The next one, we have 4x squared to the second power. So we're going to multiply 4x squared times itself, right? So we would have 4x squared times 4x squared. Again, we're going to multiply everything out. So we can write it also like this. We can have 4 times x, which is this first term here, and then times 4 times x, which is our second term. Then all together, if we combine these, 4 times 4 would give us a 16. And then all of our x's, we've got 4 x's. So 1, 2, 3, 4, x to the 4th. Here we have 5x to the 4th y, and then it's all that is being squared. So when we write this out, we have 5x to the 4th times 5x to the 4th, right? We have both of those being multiplied twice because it's being squared. But then we can write those terms out. This first term is a 5 with 4 x's and then a y, and then this term, same thing, a 5, 4 x's, and then a y. So then if you think about multiplying all these, you're going to multiply like things. So 5 times 5 would give us 25, and then we have 8 x's, so x to the 8th, and only 2 y's, so y squared. Our last example in this box, we have 3x to the 3rd y, and then the whole thing's in parentheses being raised to the 3rd power. So then if we write this out, we have 3x to the 3rd y, 3x to the 3rd y times 3x to the 3rd y, right? You're multiplying that 3 times. So then we can also write it out with every single term. It's kind of long, but we have 3x times x times x times y times 3 times x times x times x times y times 3 times x times x times x times y, right? We wrote down every variable and all the numbers. So then we can multiply our whole numbers. So 3 times 3 times 3 would be 27. And then we have 9 x's total, and then we have 3 y's. So you may have noticed that this was pretty similar to the last one. Okay, so we don't have to write out all this repeated multiplication. We can just think about distributing that power to everything inside. So instead of writing 3x times 3x, you can think of this 2 as going to the 3 and going to the x. So then our answer would be 3 squared, right? Because if you put this 2 on the 3, so we'd have 3 squared, which is 9, and then x squared. Same thing down here. If you take this 2 and distribute it to the 4, 4 squared would be 16, and then this x squared raised to the 2nd power is just like we did on the page before. When you have a power raised to another power, you multiply. So 2 times 2 would give us our 4 as our final exponent. Again, same thing here. We're going to take this 2 and kind of distribute it to everything inside. It has to go to all the different numbers and all the different variables. So 5 squared would give us our 25. X to the 4th raised to the 2nd power, you would multiply those, so you would have 8. Then here y has an exponent of 1, so 1 times 2 gives us 2 for our y's. Our last one is the same exact thing. You take the 3 and you distribute it. Okay, so 3 to the 3rd power, 27. X to the 3rd power times that 3, right? We're distributing that in. 3 times 3 gives us 9. And then y has an exponent of 1 again, so 1 times 3 is 3. Okay, so the way that we can write this in like a fancy way or an algebraic way, if we had m to the a and n to the b, and then we had everything being raised to the c power, well, you're going to take that c and kind of distribute it to everything. So it'd be m to the a times c times n to the b times c. So you're going to take that c and it goes to every single part of our term. Okay, again, I want you to try these 4 on your own, but please pause the video and try them before looking at the answers on the video. It's very helpful to try them on your own. That way, if you have questions or if you don't quite get it, you can raise your hand and ask for help, or you can watch the video once you've tried it to see where you went wrong. Okay, but if you don't try it, you're not going to know what you can do and what you can't do. Okay, pause your video now. Welcome back. I hope you tried it on your own. and let's see how we did. So 5x squared, right, you're going to take that 2 and distribute it inside. So you would have 5 squared and y squared, because you distribute it to all the parts. 5 squared is 25, and then y squared we're just going to keep as y squared, because you can't do anything else with that. We don't know what y is equal to, so 25y squared is our final answer. For our second example, we're going to take that 2, and again we're distributing it inside, right? You want to put it on the x and put it with the y. So then putting our exponent of 2 onto x, we'd have x squared, and then when you're combining it with the exponent on y, you're going to multiply. So 5 times 2, it gives y to the 10th. Our third example, we have 3x to the third y, z to the second power, and then that's squared. So then here what we're going to do is, again, we're going to put that 2 on every little piece, so every single variable and coefficient. So 3 squared is going to come first, then x to the third power raised to the second power, we're going to multiply, so you get 6, y squared, and then 2 times 2 gives us 4. So then the only thing that we have left to do is 3 squared is actually 9, so then this would be our final answer. 9x to the 6th, y to the 2nd, z to the 4th. Alright, our last one on this page, we have 5xy cubed, and it's raised to the second power. Again, we're going to take that 2, and we need to distribute it to every single piece, right? To our 5, to our x, and then to our y. So then if we look at what that's going to look like, we'd have 5 squared is 25, x to the first power, and then raised to the second power would just be 1 times 2 gives us 2, and then y to the third to the second power, 3 times 2 gives us 6. Okay, we have one more type of exponent rule for this part of our notes, and it's the power of a quotient rule. So remember, quotient means divide. So all of these are going to have some sort of fraction or division problem in them, and all of them are going to be raised to an exponent. So for our first one, we have 1 over y, and it's to the second power. So then when we write this, it's going to be 1 over y times 1 over y, right? You're multiplying that out twice. So then in simplified exponent form, you would just multiply across the top and multiply across the bottom, just like you would do with normal fractions without variables. So 1 times 1 would give us a 1 in our numerator. Y times y gives us y squared in our denominator, right? We would add our exponents going across. The next one we're having x divided by y, all raised to the second power. So again, you're going to write it out as x over y times x over y. And so when we multiply across our numerator and denominator, we're going to get x squared and y squared, because we have 2 of each of these. So you would add your exponents of 1 to get x squared and y squared. Our third example, you have x squared over y to the third, and it's being raised to the second power. So what we're going to do is multiply those out twice, right, because it's being raised to the second power. So x squared divided by y to the third power times x squared divided by y to the third power. And again, we're just going to go straight across our numerator and straight across our denominator. Well, across the numerator, x squared times x squared, you add the exponents, okay, that's x to the fourth. Across the denominator, we have y to the third, you add the exponents, and that's y to the sixth. The last one is a little bit trickier. We have x to the second, y to the fourth, divided by y to the second power, and it's all being raised to the second power. So we're going to have to multiply this out twice, right? X squared y to the fourth over y squared, x squared y to the fourth over y squared. So then if you multiply across the top, you're going to get x to the fourth, y to the eighth, because you would add the 2's for the x squareds and get x to the fourth. You add the 4's and you get y to the eighth. Then across the bottom, y squared times y squared is y to the fourth. But then we're not quite done. We have y's on top and y's on bottom. And last time we talked about how we can simplify this, right? You can just use your subtraction rules, like subtract the exponents for the y's. So we're going to keep this x to the fourth out front. But then y to the eighth and y to the fourth we can subtract, and we get just y to the fourth. So our final answer is x to the fourth, y to the fourth. Okay, again, we can kind of shortcut this. We don't have to do all this repeated multiplication. The one way we can think of it is that this exponent outside gets distributed to everything in the numerator and everything in the denominator. So for example, this 2, if it goes on the 1 squared is just 1, which is in our final answer, and then y squared is y squared in the bottom. Same thing happens here. In our second example, we have the squared being distributed to the top and the bottom of our fraction, and we're going to get those squareds on both our x and our y. For our third example, when we distribute that squared, you already have exponents here, so you would actually multiply them, just like the power to a power. So 2 times 2 would give us our 4 as our exponent for the x, and then 3 times 2 would give us a 6 for our exponent on y. For our last example at the bottom, the same thing happened, that squared is being distributed to everything. Okay, so x squared raised to the second power is x to the fourth. Y to the fourth raised to the second power is y to the eighth, and then it also goes down to the bottom. So 2 times 2 gives us 4 on the bottom. But then we actually had to keep simplifying from there. So it took one extra step, but you can still distribute that outside power to everything inside. So then let's write our rule for this one. So the way that we can write this using algebra, okay, so if we had x to the a over y to the b, and everything's being raised to the c power, they're just saying that you're going to take that c and multiply it by every exponent. So you would have x to the a times c and y to the b times c. Okay, up here we've got 4 examples for you to try. Again, you should pause the video, try it on your own, and then come back and check your answers. Okay, I hope you paused the video and tried it on your own before checking with the video. So for this one, we're going to take that 2 and distribute it to everything involved. So we would have 1 squared on the top, right, because you put the 2 on there, and then z to the fourth, because 2 times 2 gives us to the fourth. Well, 1 squared is just 1, so our final answer is 1 over z to the fourth. Our second one, again, we're going to take that 3 and distribute it to the numerator and everything in the denominator. So we would have 1 to the third power, which is just 1, so I just wrote our 1 there, x to the third power, and then y to the 15th power, because you would multiply 5 times 3, because this is like power to a power, where we multiply. For our third example, we're going to take that 2 and we're going to distribute it to everything on the top and everything on the bottom. So then our x had an exponent of 1, so then 1 times 2 would give us an exponent of 2, so x squared. Z already has an exponent of 2, so 2 times 2 gives us 4. And then y has an exponent of 1, so 2 times 1 would give us 2 on the bottom. So our final answer there is x squared z to the fourth divided by y squared. Our last example that you should have tried on your own was x y to the fifth divided by y to the third, and it's raised to the second power. So we can distribute that second power to everything on the top and everything on the bottom. So then we would have x to the second power, because you would put on the x, y to the 10th, because you'd multiply those two, and then divided by y to the 6th, because you'd multiply those two. Then from there, we still have to simplify though. We have y's on top and y's on bottom. We don't want both. So we're going to actually use our division rules where we subtract our exponents, and 10 minus 6 gives us 4. So x squared y to the fourth is our final answer there. Okay, on the next page is a practice 1. You should try it, ask questions if you need to, and I will check it when you are done. So please try your best.